Hey everybody, welcome to the first of a series of 3 videos that I'm going to be making over trigonometry with right triangles. This first video is going to be focusing on 2 things specifically. First, it's going to be making sure you can understand what the 3 basic trig ratios are so you can set the functions up correctly, as well as use those ratios to find the lengths of sides of a right triangle. The next video will focus on how we'll use those same ratios to find the measurement of an angle of a right triangle, and then the third video will focus on some word problem type examples where we're going to be looking at some vocabulary referring to, say, like an angle of elevation or an angle of depression, things like that. So first of all, what is trigonometry? If you just look at the way that the function, or not the function, but the word is written, like you understand just kind of how words are kind of put together sometimes. If this is going to be the study of triangle measurements. The study of triangle measurements. Now, one of the things that we're going to be looking at in our curriculum here, or any kind of thing that you look at for trigonometry, we're going to be looking at angles inside of them. Now, the most common angle symbol that we look at here is theta. It's kind of an O-looking shape with a horizontal line through it. That's the most common, probably, Greek letter that they use to represent an angle of reference in trigonometry. But you might also see kind of this A-looking shape like this. That is alpha. That is also pretty commonly used as a symbol to refer to a specific angle that you're talking about. And another pretty common one is kind of this B-looking shape. It's kind of like an italic-looking B with a tail on it. That is beta. There's others that we use, but these are just some common angle things are symbols, Greek letters that we use to represent an angle of reference that we're talking about in a right triangle. So the first thing I want to make sure that we can do is understand what the 3 basic ratios are and how they are created. So there's 3 basic ones. We have sine. Okay, sine is a ratio of the leg that is opposite of your angle of reference to the hypotenuse. So let's say that we're going to be looking at sine of A. So I'll do sine of A in this blue color. And I'm going to put theta here to show that's the angle that I'm using as my reference. Well, we need to know what is the side opposite of it and what is the hypotenuse. So imagine you're standing in a triangular room like this, and you're in this corner, and if you look across the room, well, across for the room from you, this side here, that's called side A, this is the side that is opposite of angle A. And that's usually how sides and angles are named in a triangle. So here we use capital letters to represent the angles and lowercase letters to represent the sides. But the side that is opposite of the angle is the same letter, but a lowercase version of it. So here is angle B, so the side opposite of it is angle side B with the lowercase letter, and so on. Well, the hypotenuse is always going to be whatever the angle is, or whatever the side is that's opposite of the right angle. So here, this side is going to be the hypotenuse, side C, because that is the side that is across from the right angle. So by process of elimination, this side here, B, this side would be the side adjacent to the angle, that is not the right, or that is not the hypotenuse. So from this angle, this is how we're labeling all three sides. The side across from it is the opposite side. The side next to it that is not the hypotenuse is the adjacent side, and the hypotenuse is always going to be whatever is across from the right angle. So in this case, if I want to know the sine of A, we're looking at the ratio of the opposite side to the hypotenuse. Well, the opposite side in this case is A, and the hypotenuse is C, so I would write the ratio as A to C. Well, now let's change directions, and let's look at it from the second angle. Let's look at it from angle B, and let's put alpha here to represent a different angle measurement. I didn't really make my alpha symbol super great there, but you get the idea. Well, imagine that somebody else is sitting in this corner, and they're across, the side across from them is side B. So this is the side opposite of angle B. Now the hypotenuse is always just the hypotenuse, so it doesn't change even though we changed corners in the triangle. And now the side that makes up angle B but is not the hypotenuse, this is now the side adjacent to angle B. So if I'm looking to make the ratio of the opposite side to the hypotenuse for sine, in this case I would say B over C. So that's what I'm going to put here, B over C. And we'll kind of do that same thing for the other ratios that we're going to be looking at. In this case, we're going to be looking at cosine. So cosine is the ratio of the side adjacent to the angle and the hypotenuse. So the side adjacent to the angle, in this case, if we go back to angle A, the side adjacent to the angle in this case is side B, and the hypotenuse again doesn't change. It's always the hypotenuse, whatever is opposite of the right angle. So in this case, the ratio of the adjacent side to the hypotenuse would be B to C. And if we change where we're sitting again, if we're looking at this angle, again, the side adjacent to the angle now is side A, and the hypotenuse is still the hypotenuse. So the cosine ratio of the adjacent side to the hypotenuse from this angle would be side A to side C. And the third basic ratio that we're looking at for right triangle trigonometry would be the side opposite of an angle and the side adjacent to an angle. So again, once you've labeled them in the figure, the sides don't change at all, but just the angle of reference might. So once you have them labeled, you should be okay. So the ratio for tangent is the side opposite of the angle and the side adjacent to the angle. So in this case, opposite is A and adjacent is B for this angle A here. So I'm going to say A to B. And if we switch back, going back to this corner here at angle B, now my opposite side is here, B, and my adjacent side here is A. So the ratio would be B to A. And that is what it is asking us to be able to identify. Based on where the angle is located, the opposite side and the adjacent side can change, but the hypotenuse will never change. It will always be the side opposite of the right triangle. So now let's take a look here. Okay, let's try to simplify things a little bit. Sine, in this case, is going to be, based on what we're seeing in this definition, sine is the ratio of the opposite side to the hypotenuse. Now what we do here, there's a mnemonic device that we use to try and help us remember the ratios without looking them up, and we're just taking essentially the first initial of each part. So I'm going to take the S, the O, and the H, and we put them together like this and just say so. SOH, where we say sine is equal to the opposite side over the hypotenuse. It's just a mnemonic device to try and help us remember what this ratio is. The next ratio, cosine, is adjacent to the hypotenuse. All right, I got distracted. I had a phone call that came up, so I had to pause the video from recording it. So back to where we were talking about the cosine ratio as being the side adjacent and hypotenuse. And so the acronym that we would have to help us for our mnemonic to remember what we're doing here is we're going to say CAH, Ka. So that's the mnemonic device that we use to help us remember cosine, where cosine would be the ratio of the adjacent side over the hypotenuse side. And the last one that we would take a look at here would be tangent, where tangent was the ratio of the opposite side to the adjacent side. And again, we're going to use the same little trick here, the leading or the first initials of each term. And the mnemonic that we're going to have here for tangent is TOA. And so generally speaking, we would just say the mnemonic device in general is just so, ka, toa to help us remember the relationship for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Excuse me. So moving on, again, the first thing that we're really trying to do here is just, can we identify the ratios correctly, and then can we use those ratios to find the lengths of sides of a right triangle between something that we know and something where we're given an angle. So let's take a look here. I'm going to do example 1 for you, and then I want you guys to try and do 2 and 3 just to make sure that you're understanding and picking it up, okay? So here at angle A, we're going to say, all right, let's make this angle theta. So from here, from this angle, the side BC, where the 5 is, this would be the side opposite of the angle. The side here, AB 12, would be the side adjacent to the angle because that is the side that makes up the angle but is not the hypotenuse. And the hypotenuse is always going to be the side opposite of the right angle. So this side here, AC, is going to be the hypotenuse. So if I'm looking at the ratio for sine of A, sine is opposite over hypotenuse, that would be 5 over 13 in this case. Looking for cosine of A is the ratio of the adjacent side to the hypotenuse. So in this case, that would be 12 to 13. And the tangent ratio is the opposite side to the adjacent side. So from this angle, that would give me 5 over 12. And then we would switch, and we would do it from a different angle now. In this case, they're saying sine of C, so that's this angle here. So let's put beta, I guess, here to represent the angle that we're looking at now. Well, from this angle of reference, the side opposite of it is the side AB. The side adjacent to it is the side BC. And the hypotenuse is still just the hypotenuse, the side opposite of the right angle. So now we're going to look at the ratio for these the three trig ratios from this angle C. So in this case, sine opposite over hypotenuse would be 12 over 13. Cosine ratio adjacent to hypotenuse, in this case, would be 5 over 13. And tangent of C opposite over adjacent would be 12 over 5. And I like the fact that I like how they're kind of putting them together like this because it makes it a little easy to see some relationships that we can recognize is that the sine of one angle and the cosine of the other angle, these are the same thing. So the sine of this angle and the cosine of this angle also are the same thing. It's not often that you would necessarily have to make that connection, but if you're just kind of writing them out like we are in this case, it can make them a little easy to do. And the relationship, what we're seeing here for tangent, the tangent of one angle and the tangent of the other angle, they're the same values, they're just reciprocals of each other. So the sine of one angle and the cosine of the other angle, those are the same for the two angles that we have, and the tangent ratios are going to be reciprocals from one angle to the next. So at this point, what I want you to do, I'm going to have you guys pause the video and try working out examples 2 and 3, and when you're done, hit play so you can check your work and see how you're doing compared with mine. Alrighty, and let's see how we did. Check your ratios with mine, and hopefully everything came out okay. You do want to make sure that you simplify your ratios. On 2 and 3, they added one extra step where you had to use the Pythagorean theorem to find the missing side, which is a pretty common strategy, just to throw in that extra skill to make sure you're understanding how we're, what we may need to do to evaluate the triangle completely. But now let's move on to the next bit here, where we're asked to try to solve some triangles. Okay. Now, what it's asking us to do, it says round x to the nearest tenth, and this is something that we definitely need to make sure that we're using a calculator for. Now, speaking of calculators, let's go ahead and have a discussion about different types of angles that we can see or that we can use. So I'm going to just use a little bit of this blank space here. Okay. Mostly what we do in geometry is we do things in degrees, where we can say, I don't know, if we're on a graph like this, we can have something going like this, and this degree right here might be a 45 degree. Okay. Well, in math, there's more than one way to measure an angle measurement, just like in there's more than one way to measure the length of a segment. I can measure a segment to be in inches or centimeters or kilometers or miles or yards, or a whole bunch of different ways I can measure the length of a side. Well, I can do the same thing with an angle. Okay. And I know I'm not drawing my circle here very nicely, but let's say that this is 1 and that this is 1. Well, what we're doing here is I can say whatever the length of this is, where that's 1, so I can pick up that piece from here to here that's 1, and I can lay it out on the circumference of the circle. And so what we get here is that angle right there, instead of being measured in degrees, that would be 1 radian. And that is another way of measuring an angle. And depending on your calculator will work in different degrees or radians. So here's just a random scientific calculator that I have, and depending on the layout that you have, Texas Instruments does a lot of things pretty similar to this. So if you're using, say, a Casio or something, you may need to look up how to make sure you're in degrees. Now, this particular calculator, if I hit the mode button, the very first row that I see here is giving me the option to be in degrees, radians, or gradians, which is just a different way of measuring an angle, but almost exclusively we would be in degrees or radians. Now, you can see that my calculator currently is in radians, and I don't want it in radians when I'm doing trigonometry in this class because we're doing everything in degrees and not radians. You know, when you do trigonometry again in pre-cal or calculus, then you will be working more in radians than you will in degrees. But for now, we want to be in degrees. So now that I have that, and now a lot of us are probably using one of these calculators here, where we have an Inspire of some kind. And the way that I'm going to do this is I'm going to make sure I'm at home, and I'm going to check the settings. So the document settings is what we're looking at here. And if you notice what it's telling you here, if you go down where it says angle, this is where we have the degree, angle, and radians thing. So if you're in using one of these calculators, you want to make sure that you're in degrees before you start doing any work in trigonometry, because if you are not in degrees, you will get the correct value but in a wrong dimension. So instead of having, you know, maybe you wanted something in miles but you got your answer in kilometers, well, that could have disastrous results depending on what your application is. Same thing here. We want to make sure that we're doing all of our work on the calculator in degrees and not radians. So make sure your calculator is in degrees, and let's take a look at how we're going to answer some of these problems here. So I'll do the first 4 just to kind of help you out, and then I'll ask you guys to do the next 4 just to see if you're picking it up okay. Now, in this case, we don't need to label all of the sides from the angles, from both angles. In this case, they're giving us an angle of reference. So this would be like theta here. Okay? So from this angle, this side that's x, that is my opposite side. This would be my adjacent side. And of course, my hypotenuse is across from the right angle. Now, when it comes to setting up a problem here, we're basically just writing a proportion. We're saying the sine of the angle is equal to a ratio. Now, in this case, we're looking for the side opposite of it. And because they're giving me the hypotenuse, opposite and hypotenuse, remember, that is the ratio for sine. So because they're, you know, let me go ahead and highlight those because those are the sides that we're using. Even though I labeled the adjacent side, I don't need it. It's not given to me, so I'm going to use the side opposite because that's what I need. And I'm going to use the hypotenuse because that's what was given to me. So this is why, again, we want to use that acronym SOHCAHTOA. So here I'm using sine. So I'm going to say sine of my angle is equal to the opposite side over the hypotenuse. And at this point, it's really just, once we have that, it's really just a plug and chug exercise with maybe a little bit of algebra, depending on what we're doing. So in this case, I'm going to say sine of the angle 28 is equal to the opposite side, x, which I don't know, over the 19. Well, to get the 19 out of the denominator and get x by itself, at this point, the algebra says multiply both sides by 19. So that's what I'm going to do. Multiply both sides by 19, and I'm going to get 19 times the sine of 28. And if you want to, sometimes people will put the angle in parentheses to show that it's not something outside of sine like the 19 is. And we'd say it's equal to x. And this is where you just go to your calculator. Now, I like my scientific calculator, so I'm going to use the scientific calculator. Okay? So my trig functions are right here where it says sine, cosine, and tangent. I know on the Inspire it's going to be in a different spot, but I'm going to type it in just like this. Now if I wanted to, I could leave my answer like that and say that is the exact answer. But most of the time it is asking us to round to the nearest tenth. Now of course, us being the type of class that we're going to be working in, we don't want tenths, we want thousandths, 3 decimal places. So everything that we'll round for a side, we will round all of our sides to 3 decimal places. So I'm going to turn my calculator back on, and I'm going to just type it in just like it's written. I'm going to say 19, and I'm going to hit sign, and I'm going to type in 28 for the angle. And if I close the parentheses or don't close the parentheses, the calculator knows if I hit enter here, it's going to close the parentheses for me automatically. And so there is my length of the side. I can say 18.919, so if I round that to 3 decimal places, that would be 18.92 or 8.920. So I would say 8.920 is approximately equal to x. And that's what we would be looking at as the solution to the problem. So let's try another one and just see how we do. And if you feel comfortable with it, you're more than welcome to, try and advance the video and work your way through them as quickly as you want to. So here's my reference angle. This is theta or alpha or beta, whatever you want to call it. So this is the side opposite of the angle. This is the hypotenuse because it is opposite of the right angle. And this would be the side adjacent to my reference angle. So we're looking for x. So in this case, I'm looking for the opposite side again. And instead of this time giving me the hypotenuse, this time they've given me the adjacent side. So the opposite side and the adjacent side, if you refer to your SOHCAHTOA acronym, opposite and adjacent, says that we're going to use the tangent ratio. So I'm going to say tangent of the angle is equal to the opposite side over the adjacent side. And now we'll start substituting some things in. So in this case, I have tangent of 41 is equal to the opposite side, which is x, over the adjacent side, in this case, is 32. And just like what we saw in the last example, we have to get the 32 out of the denominator, so I wind up multiplying both sides by 32. And I will get 32 times the tangent of 41 to be equal to x. And again, at that point, technically we could stop. That is the exact answer in degrees. But I will go to the calculator here, and we would just say 32 tangent of 41 and hit enter. And there we go. So I would say 27.817. So 27.817 is approximately equal to x. So let's move on to the next example here. So from the angle that we're given, this is the side opposite of the angle. This is the hypotenuse because it is opposite of the right angle, and this is the side adjacent to my reference angle. So in this case, the side that we're looking for is the adjacent side, and the side that they gave us is the hypotenuse. So here, adjacent and hypotenuse says we're using the cosine ratio. So cosine of the angle is equal to the adjacent side over the hypotenuse. So start substituting your values. Cosine of 21 degrees is equal to the adjacent side over the hypotenuse. And again, one more time, we can see that to get x by itself, we have to multiply both sides by 26 to get it out of the denominator. And that will give me 26 times the cosine of 21 to be equal to my adjacent side x. And after that, it's just calculator time once again. So I'm going to say 26 times the cosine of 21. And I would get 24.273. So 24.273 is approximately equal to x. And so let's take a look at one more example together, and then I'm going to ask you guys to try and move on here. Actually, I might do one more for you just to make sure that you see something with my assistance without trying to do it the first time here. Well, let's take a look at this one and see how things go. So here's my angle. So this is the side opposite of the angle. This is the side adjacent to the angle. And of course, the hypotenuse is opposite of the right angle. So in this case, the two sides that I need is the opposite side and the adjacent side. And so once more, opposite and adjacent, TOA tells me I'm using tangent. So I'm going to say tangent of my angle is equal to the opposite side to the adjacent side. So tangent of 55 in this case is equal to x over 8. And we will multiply both sides by 8 to get it out of the denominator. Oh, and I've been sitting in my chair too long, and my lights just turned off. Here we go. Make sure everybody can see okay. Multiply both sides by 8. And I will get 8 times the tangent of 55 to be equal to x. And again, at that point, it's just a calculator, plug and chug thing. So I say 8 tangent of 55, and I hit enter. And I would say that x in this case is approximately equal to 11.425. Now real quick, let me just demonstrate the difference between the measurement that we're getting here in degrees and what it would be in radians. Because usually if you're in radians, you're going to get some strange looking numbers that just don't seem to make sense. So I'm going to go back to radians here. Okay, and I'm going to type in the same thing. I'm going to say 8 tangent of 55. And if you notice, we get a negative number here. And you should recognize that is not possible. I cannot have a length of a side of a triangle that is a negative number. And that is simply because of the difference in angle measurements in the way that they're being done. So make sure that you're in degrees. If you try to do your stuff in radians, you're probably going to get things that don't make sense. Okay? So, at least for the time being, they won't. So I do want to take a look at number 8 for you here with you. Actually, let's do 8, and then I'm going to ask you guys to try and do 9, 10, and 11, just to make sure you're understanding them, okay? And in this case, the reason why I want to do it is because of the algebra associated with it. This is where some students have a tendency to struggle as a beginning trigonometry student. So this side here is the side opposite of my angle. This side here is the side adjacent to my angle. And of course, this is the hypotenuse because it is across from the right angle. So the two sides that we need for this particular problem will be the opposite side and the hypotenuse. So opposite and hypotenuse is telling me that we're going to use sine. So I'm going to say sine of my angle is equal to the opposite side over the hypotenuse. Now when we plug in our values here, we don't do anything different. I'm going to say sine of 33 is equal to the opposite side, 15 over x. Now this is the first one where we have seen the variable in the denominator, and the reason why I wanted to do this one is because what I have a tendency to see students do is they see like examples that we did in the first 4 where x was in the top. Well, now x is in the bottom. And what I see kids try to do is they still want to say, let's multiply by 15 in this case and say that x would be equal to 15 times the sine of 33. Well, in this case, that's not the case. We still have to multiply whatever's in the denominator to move it from one side to the other. And when I do, the x's on the right side are going to simplify to be 1, and I'm going to now have x times the sine of 33 on the left side of the problem equaling 15. Well, we haven't gotten x by itself yet. X is multiplied by sine of 33. Now, sine of 33 is just a number, so it's just like saying, 3x or something, 3 times x. So to move the sine of 33, we're going to divide both sides by the sine of 33. And on the left side, sine of 33 divided by sine of 33 simplifies to be 1. And so now I have x is equal to 15 divided by sine of 33. And that is what I could stop at as my exact answer. But in this case, we want the decimal value. So I'm going to go to my you can't see, that's very, very bright. So let's go to the calculator here, and I'm going to hit my ratio button, or I can hit my divide button. And in this case, I have 15 over the sine of 33, and that is going to give me 25.541 as my approximate answer. So x is approximately equal to 25.541. So don't let your algebra skills fail you. We're still trying to solve for x. So in this case, x is in the denominator, so you have to multiply both sides to get it out of the denominator. And then at this point here, x is multiplied by this value here, so we have to divide by it. And ultimately what you're going to recognize is that these two things wind up trading places. And x is equal to 15 divided by sine of 33 in this case, and we wind up with this. So at this point here, I want you to go ahead and pause the video and try working out examples 9, 10, and 11 and see how you do. And when you're done, hit play and check your work compared to mine. Okay, so here are the next 3 problems, 9, 10, and 11 worked out. Hopefully your answers and my answers are matching fine. And if so, great. If not, you need to please get in touch with me and let me know so we can talk about it in more detail. The last 2 that we have in our notes here are going to take a look at some word problems, and I'll do one of them for you and then ask you guys to try and do the last one on your own, see how you do. So taking a look here at number 12, it says Jake leaned a 12-foot ladder against his house. The angle formed by the ladder and the ground is 68 degrees. How far from the base of the house did he place the ladder? So here, this is a very classic kind of question. So you got your house. Let's see, our house is like up here, like there's your roof, and here. So here's the house, and he has his ladder leaning up against the house like so, where it tells you that the ladder itself is 12 feet. Now we're going to presume that the ground and the house are perpendicular to each other, hence we have a right triangle that we're talking about here. And it tells you, and we've seen questions like this kind of like with the Pythagorean theorem, but now it's telling you that the angle formed by the ladder and the ground, well, here's the ladder and here's the ground, so that 68 degrees is right here. And what it's asking us to find is how far from the base of the house did he place the ladder? So the base of the house is here, the ladder is here, so what we're looking for is this side right here. So again, if we're labeling everything from the angle, from this angle here, this is the side opposite of the angle. The side that makes up the ladder, this is the hypotenuse because it's across from the right angle. And this side here is the adjacent side. So having this diagram is going to be very helpful. It doesn't need to be much detail to it, but you do want to make sure that you can identify your parts correctly, because without it, it's going to make getting the right answer pretty difficult. So in this case, we're looking at using the adjacent side and the hypotenuse with the angle that they gave us to find how far away the bottom of the ladder is from the house. So adjacent and hypotenuse, at this point, hopefully you're starting to get the ratios down okay. a ratio, or where we're using the adjacent and hypotenuse, that is telling us that we're going to use cosine. So cosine of the angle is equal to the adjacent side to the hypotenuse of the triangle. So plugging in our numbers here, we're going to say cosine of 68 is equal to the adjacent side, which we don't know, over the hypotenuse, which is 12. And again, some simple algebra. Multiply both sides by 12 to get it away from the variable, since it's in the denominator. Multiply by 12. And we're going to end up with 12 times the cosine of 68 to be equal to x. And at that point, it's just a calculator exercise. Plug it in. So 12 cosine of 68. And I am getting approximately 4.9, nope, 4.495 feet to be approximately equal to x. So the next one is pretty similar. Go ahead and try pausing the video and work out problem number 13. And when you're ready, go ahead and hit play, and the work will magically appear on the screen so you can check to see how you did. Alrighty, and here you go with the last one. See how you did. The diagram, again, is going to be pretty important. We have a ramp that's loading suitcases onto an airplane, and the cargo door is 7 feet above the ground. So I'm trying to draw a little cargo airplane here. So here's the door that's 7 feet above the ground. And the angle formed with the ramp and the ground is 25 degrees. So in this case, we're going to say sine of the angle is equal to opposite side over hypotenuse. And doing the algebra works out to give me about 16.563 feet. And that's going to wrap it up here for the conclusion of introducing how to identify the ratios of sine, cosine, and tangent based off of where the angle is located, and how we can use those ratios to find the value of the length of a missing side of a triangle. So until next time, guys, where we'll take a look at how we find the measures of an angle of a triangle using trigonometry. Hope everything is going well with you. Be safe, be good, and we'll talk to you soon.